Possible that the retreat leaves later in the day than this?
Yeah, that's it. I don't want to come to school.
All right. So if I can have everybody's attention, please, let's talk about today's Do It, and let's go through here. Now, look, what we're looking at here is what I would call fundamentals, basics. And if you can't do the basics, you're not going to be successful. For instance, you cannot run before you walk. You cannot play baseball before you know how to throw the thing and catch the thing, and you cannot do algebra if you cannot solve equations. And within the solving of equations, there's a basic two-step. And I warned you that on the quiz, I am seeing some people who will do the first question like this. 3 times what number? Minus 1 would be negative 16. Oh, gee. That means that the 3x has to be negative 15. So, the x has to be negative 5, because 3 times negative 5 is negative 15, minus 1 is 16, negative 16. The problem with that is, first off, that is the exact right, proper thinking. But you have to show those steps, because if you don't, as we get into more and more complicated equations, which are coming in tomorrow's lesson, then you will continually get those questions wrong over and over and over again. However, if you learn how to do these properly, you won't have that issue. So the first thing you have to identify here is what's happening to the variable. There are 2 things. Multiply by 3, and then you have a negative 1 there, or subtracting 1, however you want to look at it. What I want you to always do in this particular case is begin by looking at the plus or the minus. In this case, I like to call it a negative 1. So I'm going to do the opposite and put positive 1. Die. I didn't touch the 3x, it's still there. Equals negative 16 and 1 is negative 15. Then I divide by 3 using inverse operations, and I get x is negative 5. And that particular question, as well as all the rest here, you must be perfect at in short order. You should look at it and say, Mr. Lindquist, please give me a test of 25 questions just like that, because I will get 100. That's what, when you are that confident in it, that means you can now do the fundamental. And once that fundamental is being able to be done, I can now progress to the more complicated types, and you can understand those. If you don't understand this, you will never understand those, okay? God bless. God bless you. Now, here's the bottom line. If for any reason, when you leave this classroom today, you cannot look at a question like that and say to yourself, that is super easy, you have to be at extra help tomorrow. You don't really have a choice in the matter. Okay. Oh, by the way, I was at the library last night. Phoebe was down there working on her relearn packet. She's now done. Some of you others are working on your relearn packets, and you're running out of time because a week from tomorrow, I think, the packets are due. And one of the great places to get that packet work done is extra help. Specifically, Patrick Library is a wonderful place to get it done because we have 2 hours uninterrupted as opposed to a half an hour. So I strongly suggest you get started on that. Make sure you at least begin it tonight so that you can get 1 day of extra help in tomorrow morning, and then we can continue to get that done next week. If you don't, and you try to do it at the last minute, I'm not going to have sympathy. If you try to cram it all in on the last day and you wait till then, don't expect me to turn around and say, oh, don't worry about it, you can do it tomorrow, because you've had 2 weeks by the time we hit that date. Okay, next one. The only difference between letter A and letter B is in letter B, I put the x on the right-hand side. And I do that to emphasize to you that where the x is doesn't matter. Now, one of the very big common mistakes that people make is this. Make sure you're looking. Ready? They do plus 3, plus 3. It's a very common mistake, because they're so used to starting on the left, because most of the textbooks and most of the teachers make examples where the letter's on the left. But you don't start on the left. You start where the letter is. The letter's on the right. So where do you start? On the right. That says positive 7, so you do negative 7. Die. Negative 3 and negative 7 is negative 10, is equal to 2x. Divide by 2. Negative 5 is equal to x. Okay? It's just purely coincidence. Next. This guy is the danger moment. Second most deadly type of math equation problem in the whole world. One little bite from this beauty, you're gonna. Got to be very careful with this question. You should look, as you as you see this, you should be saying to yourself, man, that -2, danger zone. Got to be very, very, very careful. You know how there's certain places where maybe when you were a little kid, you rode your bike down the street or you walked down the street and there was like this big, vicious, horrible dog? And you just knew that when you got to that particular section, you just crossed the street. Or if you're walking down the street and you just see a bunch of like criminals, and you know that these are like bad news kids. Oh, you laugh. You can see them. They all got their pants around their ankles. The hats are turned to the side. They got 22 pounds of bling on. They walk like, and they just look like they're trying to intimidate everything on the face of the earth. I actually had a pretty fun time with them going back about a year ago. I was walking Gibbs and Ziva.
What?
I was walking Gibbs and Ziva dogs,
Oh,
right? And I'm going down the street with Gibbs and Ziva, and they're bebopping, and Gibbs and Ziva are giving them the eye, like. So then the leader of the bunch, trying to act all tough, he goes, "Yo, you mind if I pet your dogs?" Go right ahead. Comes walking up. Gibbs goes into full arch lion mode. Ziva stands up on her two back legs and starts charging the guy. He goes running away like, "Oh, no, we don't need to pet them. We don't need to pet them." I was like, "Good doggy, good doggy." And then we were walking down the street the next time, and there were like 14 of them coming down the side of the street I was on, and this was at night. And they see the dogs, and the dogs start growling, and they all cross to the other side of the road, and they're like silent. There's no words. And they get like 100 feet past me and go, "Yo, man, I kicked that dog's butt. I housed that dog. They're using a bunch of curse words. And I'm like, "Yeah, right. Okay, sure. Anything you say, buddy." This is the big, snarling, ugly dog. You got to be aware of it, all right?
Ugly?
No, my dogs are beautiful. They are. But this is the one that you need to stay away from. You need to know what makes it bite. And what makes it bite is that negative sign there. So you have to be very, very well aware of it. What kind of 3 is this?
Positive.
Positive. So I'm going to first do -3 to both sides. The big mistake people make is they put a positive here because they see the negative there. That's completely wrong. 3 and -3 add up to nothing. Die. That's a -2x. And here's the other big mistake that people make. They bring down the 2x, but what do they forget? The negative. Don't forget that negative. Is equal to 13 and -3, or 13 minus 3, however you want to do it. Die. X is -5. Something about a -5 that's going on there today. That's not the one you got like 1.83 on, was it? No. The next one? Okay. Now we're going to distribute here. As soon as I see the number outside the parenthesis, I distribute. In the English language, what does the word distribute mean? Give out. So I'm going to give out the 4 to everything in the package. Sometimes there's more than 2 things in the package. I give it to everything in the package. 12n minus 20 equals -42. Add 20 to both sides. Die. Oh, die over there. Sorry about that. 12n equals -22. Divide by 12. And folks, unless it says to simplify, -22 over 12 is fine. You don't need to convert this to a decimal. Now, if you were to convert it to a decimal, for some reason, Emma's calculator was having a brain spasm because you said it wouldn't convert to a fraction when you go back again.
Yeah, Maya did.
But Maya's did. Was there something, you're not hitting the right button?
No, she did. I was just doing something wrong.
Okay, all right, good. I'm glad that was the case. Now, if you convert it to a decimal, so often I see people get it wrong. You said it was -1.83 repeating?
Yes.
I see people do the following, -1.8, because they round it off. They just unilaterally decide where they're going to round off to. And then I see people do this, -1.83, and they'll put the line over both of them. Or I'll see this, -1.8333. They're wrong. Every one of those answers is wrong. This is right. 1.83 with a line just over the 3. And if you did that, you would get full credit. I wouldn't deny you credit. But my point is, why in the world would you take the time to do that extra step? Why wouldn't you just leave it? So if I were using my calculator, I would do -22 divided by 12, and then I would go math, enter, and I think it would say -1 and 5/6?
No, -11 over 6.
-11 over 6? Yes. Oh, it didn't convert to a mixed number? No, okay, negative 11 over 6 is fine, and that's also happens to equal negative 1 and 5/6. It's the same thing. Okay, so either one of these would be fine too. All right, any questions? Preguntas? Yes?
Let me see. What would happen if that 3 was a negative?
If the 3 was a negative, then I would do plus 3, and I would get 16 over here. All right? Any other questions? All right. So, again, those are fundamentals. One of the Mets announcers is this guy, Keith Hernandez. He was when he played professional baseball, he was a perennial Gold Glove winner. He won the Gold Glove every single year. And he's known as one of the, if not the best defensive first baseman in the history of baseball, one of the top 5. And he always talks about what he calls fundies. And fundies are fundamentals. He goes, see, there's your fundies, and he'll talk about it all the time, just how important it is to get these fundamental movements down pat. If you did all of those equations, and you got all of those right, you have perfect fundies. You are outstanding. Did anybody have perfect fundies? Okay. Now, the next question that's very important is if you messed up a fundie, do you now understand where you messed up your fundie? Right? Are we good? They're very important that you get that down pat. And if you are not getting it right, you must get to extra help tomorrow or you will drown. Are we clear on that? But if we straighten them out, you could swim beautifully. But we have to straighten them out. All right, let's draw a picture to represent positive 3 and negative 4. So the dark ones will be positive. There it is. Let's do positive 4 plus positive 3. Here it is. Does it make a difference which order I write them in? It's still how many blocks? 7 blocks. So it is what it is. In other words, 3 plus 4 is the same thing as 4 plus 3. Do we all agree with that? And that is the commutative property. Now, in the English language, I like to just learn how to think. I don't care if I'm teaching math or if I'm teaching history, science, or anything else. In the English language, what does the word commute mean? You actually hear this all the time. In fact, I know that there's like separation of church and state, which really doesn't mean what they think it means nowadays, but that's a whole nother conversation for another day. I know that we're not supposed to preach about God and stuff in school, but there is a moment where every one of you gets very religious. I don't care if you call yourself an atheist. Every one of you gets very religious at a particular point in time. You know when that is, right? When they're talking about a snowstorm. Oh, all the kids pray for snow. Like, oh, please, 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 please. Right? Well, I mean, who do you think you're saying that to, right? The great weatherman? so please, 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 please let it snow. Which, by the way, you don't want snow days. You want to go the whole year without snow days. Because it makes the Memorial Day vacation longer. And it makes the April one.
Snow days so you don't have to get time.
Yeah, but then, see, the way they make the calendar now, they have days blocked out where it says, if we don't use a snow day, then you get this day off. But if we use the snow day, you don't get that day off. So I believe one of them is the Friday before Memorial Day. So when would you rather have off? Would you rather have like a winter day where you sit around the house and your parents tell you to go shovel? Or would you rather wait till Memorial Day when the beach opens up? When it's the middle of softball season and you have a tournament. Know what I mean? And personally, as one who loves to fly fish, I choose when the weather is very good. Now, you hear the word commute whenever you're paying attention to the weather in the wintertime. Because you will hear them say, and for tomorrow's morning commute. Does that ring a bell?
Yeah.
Okay. Yeah, the commute is when people on Long Island or in the suburbs anywhere, in the mornings they get in and they drive to New York City, right? And then there's not only a morning commute, there's a what? Afternoon commute. And then they do what? They get from New York City and they drive back home to Patchogue. So when you go from Patchogue to New York, and then you switch it, and you go from New York to Patchogue, that is called commuting. Another example, I don't know if you know the powers of the presidency or the powers of a governorship in a state, but they can commute a prison sentence. And by commuting a prison sentence, you switch the prison sentence. That's one of the powers that a president has. In fact, one of the things all presidents do before they're going to leave office is they grant tons of commutes. They do it all the time. It's kind of a routine thing for all their buddies. So the definition of the word commute means to switch. So do you see how it doesn't matter if I switch 3 plus 4, 4 plus 3, it's the same thing? 3, 4, 4, 3, same thing. Whenever I switch like that, I am commuting. So on your paper it says here definition of commute. You want to write down the definition of commute is to switch.
That's beautiful.
Okay? And now, do you see the switching here? Watch. I'm going to actually think of the 5 as a variable. I know it's a number, but think of it as like this symbol for a variable. Watch my finger. Ready? Patchogue to New York, and then what? New York to Patchogue. Patchogue, New York, New York, Patchogue. So 5 plus 4 equals 4 plus 5. If you remember that the word commute means to switch, then you will be able to recognize the commutative property. Turn to the person next to you. Say, commute means to switch. That was lame. Say it again. All right, that was louder but still somewhat mumbled. Now, this would be, letter A, would be what we would call the commutative property of addition. What do you think the next one would be? What would this letter be? What would that be? Commutative property of?
Addition.
What operation's going on there?
Multiplication.
Multiplication. See, it does work. Look, what's 5 plus 4? 9. What's 4 plus 5? 9. So 9 equals 9. So clearly it works. What about 5 times 4? 20. What about 4 times 5? God bless. Yes, and that's right. And didn't you, when you learn your times tables, didn't you at some point say, well, I know 3 times 7, so then I automatically know 7 times 3?
Yeah.
Right? So that made learning the times table so much easier. There's 100 times table facts. But the minute you understand the commutative property of multiplication, you take 100 and make it 50. So you learn half of your times tables in a nanosecond. Okay. 8 times 5 equals 5 times 8. That's the commutative property of multiplication. Because we see, hey, I got a question.
Okay.
Is there such a thing as the commutative property of subtraction?
No.
Why not?
Because you'll get a negative number if you switch.
That's right. Very well done. If I try to do 2 minus 5, does that equal 5 minus 2?
No.
No, it doesn't. So therefore, there is no commutative property of subtraction. Is there a commutative property of division?
No.
No, that would be reciprocals, right? Say 8 divided by 2 would be 4, and then 2 divided by 8 would be 1/4. All right, and the last one, this is an example of
Addition.
commutative property of addition. Okay, so did I do anything difficult? No, not at all. All right, so now we get to the associative property. Now, what does the word associate mean in the English language?
To a common concept.
A little bit more. A little bit more than that. You're on the right path, but we got to get a little more specific. Associate. To be grouped with. Okay? To associate means to be grouped with. For example, if you were to talk about South Ocean Wrestling, you would group that with a lot of success over a lot of years because we just won a lot. If you were to look at the players that I coach, you would say that I always seem to get really good catchers for whatever reason. The kids who catch here usually go up to the high school and catch, and they're very, very, very talented. Now, when I think of associate, I think of what has probably been told to you by most of your parents at some particular point in time during the course of the year and your lives and so on and so forth. Now, did you ever did your parents ever say to you, you will not associate with so-and-so?
Yeah.
Right? You had that speech going. I can remember my son growing up, my son had this friend, Raymond Rivera. And every single time he was with Raymond Rivera,
Do the stupidest things.
oh, no, beyond stupid. One time when he was in 3rd grade, my oldest son, Bobby, not Jimmy. Jimmy, never got in trouble at school. My oldest son, Bobby, and Raymond trashed the bathroom. They took all the toilet paper off, they threw it all over the place, they ripped all the paper towels off, they sprayed water all over it. They completely trashed the place. So I remember he got in trouble, and then I remember coming home and picking him up over my head, holding him up against the ceiling. And I said, did Raymond Rivera give birth to you? Does he pay your bills? Does he turn around and feed you? Does he put clothes on your back? When you were in diapers, did he wipe your butt? And I went through all of these different things. And I said, then why do you listen to Raymond Rivera? And the truth is, it was probably just as much Raymond Rivera listening to my son because my son got away to get in trouble at that age. So we go through it. And then I said, you will not associate with Raymond Rivera ever again. You are not going, you are not hanging out with him, you are not going near him. That's the end of the story. I'm sure you all have had similar moments. Perhaps you haven't been lifted up to the ceiling, but I am sure that you have had similar moments in your life. So if you look at associating and to be grouped with, and you remember that story about being grouped and your parents wanting to kill you at some point in your life, here the 5 is being grouped with the 4. But here the 5 is being grouped with the 8. Now first let's verify mathematically that this checks. What's 4 plus 5? 9, because I have to do parentheses first, order of operations. And what's 9 plus 8? 17. Let's do parentheses first here. What's 5 plus 8? 13. And what's 4 plus 13? 17. So either way, I get 17. That's the first thing to observe. When that holds to be true, we say that it is associative. And what we're basically saying is it doesn't matter who the middle guy is being grouped with. Here, the 5 is being grouped with the 4. Here, the 5 is being grouped with the 8. Either way it works out. We would say that this is the associative property of what? Of addition. You know why I keep making you say addition and multiplication? I was so stupid when I was young sometimes. I remember taking a quiz once in like 7th grade, and they would give me like examples of the associative property of addition, the associative property of multiplication, commutative property of addition, commutative property of multiplication on the quiz. And I remember knowing right away which ones were associative and commutative, and I couldn't figure out what was addition and what was multiplication.
What?
Yeah, I just had this complete brain cramp. I'm like, oh man, I don't know which one's which. And I screwed them all up on the quiz. And I'm going, man, you got the hard part right. How could you screw that up? So I want to make sure I emphasize so that nobody makes that same mistake that I did. Okay, now this next one, let's verify that it works first. What's 2 times 5? Because we're going to do parentheses first. 2 times 5? 10 times 3?
30.
Nice. 5 times 3?
15.
Times 2?
30.
So 30 equals 30. It clearly works. This would be not the associative property of addition, but the, not multiplication, associative property of multiplication. Yes?
Why did you circle 5s and put arrows?
I just wanted you to see here that the whole point of associative is being grouped with. Here the 5's grouped with the 4. Here the 5 is grouped with the 8. And the order that it's grouped in doesn't make a difference. It works either way. Okay? Any question on that? All right. Now this is a tough question. Think about it before you answer. Is the following an example of the associative or the commutative property of addition? Do 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 ah! Da na 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 na. Sorry. Okay. You know. Is that a U.S. softball shirt? Atta girl. Atta girl. We're getting there. Very nice. All right. Is this? Oh, I got to kill. Ready? Hold it.
You're killing it?
Yeah. Bye-bye. I had to get rid of the ink. Commutative, associative. How many vote for associative? How many vote for commutative? It's commutative. Why is it commutative and not associative? Go ahead. Yes. Look. What changed? The 5 plus 2 is still together. In the associative property, you change who you're being grouped with. Here, the 2 and the 5 stay grouped together. What's changed is it was the 5 plus 2, then plus the 7, then it becomes what? The 7 plus the 5 plus 2. So since what's in the parentheses did not change, it is not associative, it's commutative. Now some kids, when they learn the associative property, they say, I got this figured out. Look at this, I'm a smart guy. See, I know that if it looked like this, then that be a distributive. And I know that that's distributive because they're one parenthesis. Now, if I do this, I know that be the associative, and I know that that's associative because I see 2 parentheses. That's what kids think. The problem is it's not true. Because this is a situation where I have two parentheses and it's commutative. So don't say to yourself, if I see two parentheses and I change the places, that it's automatically associative. You have to see if what's inside the parentheses. Here, the C is with the B. Here, the C is with the D. That's associative. Here, the 2 is with the 5, and the 5 and the 2. It's the same thing. What's changed is the 7 was in the back, and now the 7's in the front. Okay? Now, when it comes to comparing and contrasting the associative and the commutative properties, what does the associative property do? What does the commutative property do? Talk to me. What does the commutative property do, and what does the associative property do? Go ahead.
The commutative property switches it.
Yes. And the associative? Somebody else? Pringle, what's the associative do?
It groups different numbers.
Groups,
together.
very good. Now, compare and contrast distributive and associative. What do you notice about distributive compared to associative? How many sets of parentheses does distributive always have? One. Always. Distributive is always one set of parentheses. 5 times 3x plus 2 is going to be 15x plus 10. Whereas associative is always going to have 2 sets of parentheses on either side. Okay? All right, so you now know your properties. Tomorrow we're going to go more to multi-step equations. And from there we start racing through a whole bunch of algebra.
Ew.
Okay? Hasta la vista. Vaya con Dios. Oh no, we're not ready for that yet. Yeah, I know. I was getting a little ahead of myself there.
Never watched this till we
I have been saying that since